Lesson 23, curve sketching 8, odd functions. Now, having a look at this particular function here, I've drawn it. Now, if I substitute in, say, 1, we get function 1 equals 4 minus 1, which equals 3. Putting in minus 1, so here we have this point here is the point 1, 3. And over here we'll put in this other point. And you're going to get minus 4 minus -1 cubed, which equals -3. So this point down here is -1, -3. Now this means that function 1 is equal to minus function -1. Now, if that occurs, then you call this an odd function. In other words, when you put in a value here and you get, say, 3, you put in the -1, you get the sign will change, unlike the even function. Now, formally, we'd let x equal a, so function a will be equal to 4a minus a cubed. Function minus a will be minus function a minus a cubed, which is minus 4a. This becomes now, a minus becomes a plus, a cubed, and now this is minus 4a minus a cubed, which is in fact minus function a. Now it's arbitrary whether you get the minus this side or on the other side, it doesn't matter. But now therefore we've shown that this is an odd function. And as we can see in the next example, this is a very powerful tool. Alright, now this is a more difficult curve to draw, but we'll just check to see if this is an odd function. So I'll put in function a. We get a over a squared minus 1. Function minus a is equal to minus a over, now when we square this becomes just a squared minus 1, and therefore we can see that function a is equal to minus function minus a. Therefore it's an odd function. Now if we look at this part here, factorise the bottom, we can see x cannot equal plus or minus 1. This means there must be asymptotes at 1 and minus 1, which I'll draw. Now there's another asymptote. What we'll do now, take the function and divide numerator and denominator by this x squared. We get x on x squared over x squared on x squared minus 1 on x squared. This becomes 1 on x over 1 minus 1 on x squared. Now as x goes towards infinity, this goes towards 0, this goes towards 0, so we have 0 and 1, so we have 0. So the other asymptote is the x-axis, which is here, y equals 0. Now, putting in x equals 0, we get function 0 equals 0 on minus 1 is 0. Select another point, say a half in here, and we put in a half, and we get 1/2 over a half square, which is a quarter, minus 1, which is a half, on minus 3/4, which is a half, times minus 4 on 3, which is minus 2/3. So we have this value down here. Seeing that's an asymptote, function will continue on like this. And because we know it's an odd function, it'll do the same on this side. So this point here will be minus a half 2/3. So there we go. Like that. Now, we select it. Another point, say 2. We see that function 2 equals 2 over 4 minus 1, which is 2/3. So we have another point here. That's an asymptote, and this is an asymptote. So we have the function doing this. And because we know it's an odd function, it'll do the same over here at this point, minus 2 minus 2/3. And there we have the graph. Now, if we apply the calculus, and we didn't in this case, we would simply use, well, using the quotient where we would get a possible, well, we wouldn't get any stationary points, but we'd get a point inflection here. But we have to test this by looking at the second derivative, so we would have a lot of work to do to get something very, very simple out of this. And then it wouldn't give us all the rest of the detail either. So you can see here's an example of how an odd function is very, very helpful in sketching a graph.